Back, everybody. We're just going to move right along and get into pluck. So, pluck, pick, and prop, I sometimes get confused about, but going through it and talking about it is helping. So, this one has this type constraint where F is a functor, and a functor is any data structure that implements a map method. And that is true in JavaScript for arrays. It is also true in Ramda for objects because they just make it so. So keeping in mind that f is a functor, we take a key, which comes from this object here, and they're saying this object is a functor, and then it returns a functor of values, right? So k is the key, the key name to pluck off of each object, and f is the array of functor to consider. Um, yeah, so in our demo, we're passing an array of objects. And then we get back values in a functor, which is why the values, if you see down here, are in a list. Because that makes sense. You can't return multiple values from a function in JavaScript unless it's in a container of some sort. So it returns a new list by plucking the same name property off of all objects in the list supplied. Pluck will work on any functor. In addition to arrays, this is equivalent to r.map and with the function r.propk and passing in a functor. So that's interesting. Let's grab that, right? And let's do it with this. And then we're going to grab an example and we would log this. But instead of that, we'll get back to that. Let's do this. To get ages, so we're going to map over our array here, and we're going to grab the prop of k. Uh, so we need to tell it what prop. So let's do age, and then pass in our functor, which is our array here. I don't think this is going to work, but let's see where I'm messing up. Yeah. Uh, F is not defined. Yeah, of course it's not. So we need to pass in the data. Yeah, that should work. Yeah. And we get 29 and 27, which is what we're supposed to get. But we can do all this cleanly by plucking. So pluck is going to not just, it's the same as prop age, but we're mapping over our functor, which is an array of objects in this case. So we should get the same thing, and we do. So the difference is if it was prop, will this work on a list? No, it won't. This prop isn't looping. If we did that, we should get 29, and we do. But if we use pluck, we're going to get multiple ones. Now, what's the difference between props and pluck? This takes an array of keys, and this one only takes one. But there could be many values that match the one. Here, props is going to take multiple values. And, so we could say props, age, and name, but it takes an array. There's our keys, and then it would take our object, but this is an array of objects. So let's see if this works on an array. And it doesn't because it's undefined. But if we just passed one thing to it, one object, because it says it takes an object, not an array of objects, then we would get Fred in 29. Okay, so that's the difference between pluck. Pluck is going to give us back just the values, but it's going to look through multiple objects at one time. And then there's this interesting case here where an array is an object, and the first item in the array is zero. If the property of the first item in the array is a zero, the next one is a one, next one is two. So this is saying, give me look for the property zero and give me the value. And so I'm assuming it's going to be this first nested array, which is one, two. I've got a stray semi or one, three. Oh, I see. So this one's going to pluck off. Yeah, it's going to look at each item in the list and pluck off the value that matches the property. So we're looking for zero. So in this first one, we're going to get one, and here we're going to get three, and it returns it in a list. Yeah. And it says C project, but we're about to get there. So we'll look at that in a second. Um, but yeah, so pick, prop, pluck, props. These are all very closely related with just small differences. So let's move to something pretty simple, prepend. We've looked at prepend with when Chris looked at append. So it's super simple. I'm just going to go through it real fast. We're going to take this value phi and we're going to prepend it to the list. So it'll go first and we'll get phi FIFO fum, phi FIFO fum. And if this was append, it would put phi at the end, FIFO fum phi, right? So this is like push, but it's append is like push because it is non-destructive. It doesn't mutate the array. It creates a new array. Um, you could use the spread operator, um, but we're looking at prepend, and prepend is like, is it shift or unshift? Shift. Oh, I thought I would get code completion, but I don't. It's one of the two, but it doesn't really matter because we don't use this anymore because we just don't mutate data. We're not that kind of person. We don't do them things. So prepend sticks the item at the beginning of a list. Bam. And this one's simple too. Product, this is just like sum, but it multiplies the numbers together. It takes a list of numbers and gives you a number back. It multiplies together all the elements of a list. You also reduce, because if you don't have this function, reduce is your next best way to do it. So remember, I have this library that gives me some data, and d.list gives me an array of 1, 2, 3, 4, 5. And if I wanted to sum those, I could do r dot reduce, and I could use, isn't there a binary function? Yeah. If I use binary to decorate r dot add, then it's going to pass two arguments at the same time. And then we need the initial value of the accumulator, which will be zero in this case, because zero is the identity of the addition operator, meaning that if you add zero to anything, you're going to get the thing that you add it to back, like unchanged. So one plus zero is one, 3,000 plus zero is 3,000. That's why they call this the identity operator, the identity of the addition operator. I think that's the correct way to say it. And then we know our data. We'll do our d dot list, and that should sum all the numbers. I think it's 15, and it is, right? But we could simplify this dramatically with Ramda by doing r dot sum and just passing in our list, d dot list, save that, and we still get 15. So this is just like a simpler version of reduce, but product allows us to multiply all the numbers together. So let's go back to the reduce and let's do r dot multiply. But the identity of multiplication is one, because if you multiply anything by one, you get that anything back. So 3,000 times one is 3,000. So we want to use one as our accumulator. And then if we multiply those together, we get 120. We could use recursion. The problem with recursion in JavaScript is you can get a stack overflow very quickly, um, because JavaScript is not optimized for tail call, or I'm sorry, for recursion. You could do something called tail call recursion, but we're certainly not going to get into that right now. And then reduce is essentially JavaScript's version of tail call recursion. It's essentially internally keeping up with the accumulator. Um, but that's just a side note. But to bring it back to where we are now, see, I'm doing the weave. Um, product, and then we just pass the data, and we should get back 120. And we do. So that's all product does. And if you need a sum or you need a product, or if you need to sum a bunch of values or you need to get the product of a bunch of values, there's no reason to make it more complicated than to use r dot sum for addition and r dot product for multiplication. Yep. And so this is one of these math functions, which there are not a ton of these. Um, and so then now let's go down to some interesting functions, starting with project. First time I read it, I thought it was project, but it's just project. Let me just clean up here. I'm going to start with the definition because it makes things very simple. It's a reasonable analog to SQL select statement. So it's been a long time since I've written SQL, squeal in real life, but the simplest thing is like select all from my table, whatever your table would be, and then it would give you all the records, or you could say like select name and age. Maybe there's parentheses around here. I don't remember the syntax, but basically project does the same thing as select. Um, and for some reason they decided to call it project. Maybe that's just convention. So let's look at their example, but I'm going to simplify it a little bit. I don't know why I can't get my cursor to grab this. There we go. So we've got some names. Instead of naming these objects, let's just stick it in an array, comma there, and we'll call this kids. Yeah, there we go. So now we got this nice little array of objects. So each kid has a name, an age, a hair color, and a grade. Um, and then so what we could do is if we wanted some of this stuff, we could just say r.project and here's a string array of the props that we want, right? We haven't looked at the function signature yet, but we're kind of doing that now. So we want an array of keys that potentially match the keys in the array of objects that we're going to pass. So let's do age and hair, right? Okay, so that's the first one, array of strings, and then the object. Um, and technically an array of objects. So that's going to be our kids, not my kids, your kids. And then we get a air, name, grade. Oh, sorry, these keys are strings. And we get an array of objects back, but the objects are just what we've asked for, what we've selected or projected in this case. So very concise and like, I mean, I do a lot of fetch requests from a WordPress REST API and get back like blog posts and pages and things like that. And I get this crazy large object because GraphQL is just not worth it. So I'm getting the whole array of objects back, and maybe I just want the title and the content and the permalink or something. And I could just do that. I could say WP title, whatever permalink, and then pass it in the array and get myself back a nice little object or array of objects with just the things that I want. Um, and now, if you pass something that does not exist, like hairs, we're going to get the key back, but we're going to get undefined. But it's not going to crash. I guess we could be thankful for that. So, yeah, very simple and very useful function. And so we're going to move on now to promap, which I looked at briefly the other day, and this is a very cool function. So let's do that. Okay. So promap has two definitions depending on how you use it. The first one takes a function that goes from A to B, so anything to a B, and then another function that goes from a C to a D, and another function that goes from a B to a C, and it's going to return a function that goes from A to D. Now, if you focus on the last function, the function that's being returned, it goes from A to D, right? Well, A is the first argument in our first function, and D is what's being returned by our second function. But we're always passing data last. So this function in this context would sort of be our data. We're passing a function that takes type B and type C. So what's going to happen is this function is going to take, oh, that's complicated now. The point is B to C here. B is yeah, B is what's being returned by the first function, and C is what's being accepted or taken in as input by the second function. But we're going to go from B to C in this function, and it's going to return our A to D. Just keep that in mind. But we also can use this with profunctors. And I'll explain what a profunctor is in a second. It's just like a more fancy version of a functor. And remember, a functor is a data structure that implements a map method. It also has to obey the two functor laws, which is that it has to be composable and it has to obey the composition law, and it has to obey the identity law. And you can look into those more in depth yourself if you'd like to. I believe in you. You can do it. Uh, Otherwise, if P is a profunctor, the definition is the same thing, except that it takes a profunctor of B's and C's and it returns a profunctor of A and D's, right? So this works with a profunctor and doesn't. That's probably pretty confusing. Let's look at this. This gives us a lot more information that's useful. This A to B function, we call it F. It's the preprocessor function. It goes from A to B. And the second function, G, is the post-processor function that goes from C to D. And then we take in a profunctor, right? Like this one, a profunctor of B's and C's. Profunctor instance to be promapped, and example from B to C, like this B to this C. So the output of this one to the input of this one. And it returns a profunctor, the new profunctor instance, which goes from A to D. It goes from this first value to the second one. Remember, this is a pre-processing function. This is a post-processing function. So armed with that information, let's look at the example that they have, which I think is pretty good. I struggled to find a different one. I'm going to break this up. So this is taking, in this example, we're using promap here and here. So we're using two promaps in this. And the key thing to remember, or the first thing to remember, is that promap is going to take three functions as the arguments. And here's three functions. And then let's go ahead and just get this nice and tidy. That's, we're using promap again, splits the first function, joins the second one, and map is the third. And then we call it, or actually we call this second function decode with this value ZIULI. And we're going to log that. And before we run it, this is what's going to happen. We're going to call decode string with this string here. And we're going to run this first function, which is the pre-processing function. So it's going to run, and it's going to split this into an array of characters. Then we're going to run the function here, the third function, the B to C. Let me make sure that's right. Yeah, we're going to run r.map decode char, which is going to call this function. And then once that's done, this line r.map, then we're going to run the post-processing function and join the characters back into a string, right? So this is the pre-processing, this is the post-processing, and this is your function. And this would be handy if you wanted to partially apply decode string, which is the pre-processing and the post-processing. And then you could use it over and over again with different functions, which they call the profunctor instance to be promapped. So since this one is calling decode char, which is another function, it's being promapped. So it's going to take a string and it's going to give us the char code at that string, like the number representation of that string. And we're mapping, so it's going to do it for each one. And then we're going to get Okay. So we're going to do that first, but then we're going to go in and we're going to add -8. So that's another way of saying subtract or flip, subtract -8. It's just a way to, an easy way to do subtraction and not worry about the order that you're passing the arguments in. And then after that, it's going to convert the number for that letter back to a string. And at that point, it would go back here. We'd be finished calling that, and we're going to call join again. So let's see what we get. We run that, and we get the string Ramda. Because what we're doing is we're taking each of these letters, like we take Z. Well, first, we split this. So now we've got an array of blah, blah, blah. In fact, this only takes 3 arguments, but we can make the first argument a pipe just so that we can tap into the pipe with r.tap and log it. And that way we can see what we're getting as we step through this. And so the first operation is we're going to split it, and then we can look at that, and we get these 5 letters. But then we run this, and we map through this letters and decode each char. And so we're getting, I mean, if I do a pipe here and r.tap log that, we get the char code. So the char code for Z is the number 122, and for I, it's 105. Um, but then remember, we don't go to the next function like a pipe or something. We go and run the uh, this function, the B to C function. So we're going to subtract 8 from each char code. And then after we do that, we're going to convert it back to the character code for that number. And we still have an array of, at this point, strings, but different letters, you know. And then we, that point, go down here. So we're done running this function. And we run our post processing function, which is to join the string together or join the array together into a string. So I'm going to undo this, get rid of the pipe just to clean it up. And just to drive the thing home, when we call decode string, we're going to run the split, then the map, and the map is using this callback up here. So we're going to call this, and then this, and then this, and then this. So I think, well, for partial application, it's necessary to pass it in this order, but you could also just pipe it. We could do the same thing with one pipe, I think. Do it down here. And we could even use flow, but I'll use pipe. Um, so the first thing we'd want to do, just put them in order, like left to right. Damn you prettier. Here we go. All right, so we're going to split it, and then we're going to, come on. Okay, split it, and then we're going to map decode char. Yeah, so we'll have to put all of this in a map. Actually, I think the easiest way to do it is just to call map several times. Not the most efficient, but I don't care. I mean, we're working with a string of 5 letters. Like, I don't think we're worried about efficiency. So we're going to do that, and then we're going to do this, and then we're going to do this. We need to map that as well. And then we're going to need to do, let's see, from there, that's the post-processing. Then we get back here and we join it together. And let's see if that might work if we pass it some data. And that data was that weird word, this. So clear that, and we get Ramda. So this does the same thing. And, this is what I would do initially. But if I found that I was repeating a lot of these functions in a pipe, where I was always splitting it at the beginning, I was always joining at the end, um, I might go for promap and partially apply everything except for this last function, which would be the function that would be different. So that way you could like validate or sanitize the input coming in and sanitizing the output going out in between, or and then in between that you would have like whatever your special use case function is. But if you do it like this, it's definitely easier to um, kind of keep up with what you're doing. In fact, let me just put this in between each step. And since we're logging it, we don't need to log. Since we're logging at the end, we don't need to log the whole thing, right? So we start with our string, we split it, we subtract 8 from each character, or these are the character codes we get. Then we subtract 8 from each of those. Then we convert that back to its character representation, and then we join it together. Yeah. So that's what promap does. Um, so we've looked at some, we're taking some time here, but the next one is prop, and we've looked at prop, right? And I don't know if we've looked at all these other ones, but we've got prop, prop equals, prop is, prop or, props, prop satisfies. And then we're done with our P functions. We get into the R. So why don't we stop here and we'll pick back up in the next video, do a quick review of what prop is because it's so useful. And then we'll look at how these other ones work, which are just more specific versions of prop. So thank you for spending your time with me. Tell a friend, and I'll see you in the next video.